Hi, this is the fourth of 7 videos for week 3 and covers triangle identities. These videos are intended to help you to work through the online content for week 3. We recommend that you watch this video with your pen and paper and pause at the relevant times to do the examples for yourself. Triangle identities. Looking at the angles of any magnitude, we drew this angle as below. Using our Pythagoras theorem on this triangle, here we have our value here of x. Here we have the height of y, we have our right angle between, and we know our hypotenuse here is 1. So x squared plus y squared is equal to 1 squared. And if we look here at our angle theta, sine theta is y divided by 1. Sine theta, y divided by 1 is equal to y. And cosine of theta is x divided by 1 is equal to x. So here, rather than writing x, we can write here our cosine squared theta, rather than y, our sine squared theta is equal to 1 squared, which is equal to 1. And we know this as the first of our Pythagorean identities. So we'll be using these in further calculations. So if we take this equation, our sine squared theta plus cosine squared theta is equal to 1, and we divide throughout by cosine squared theta. So here, these ones will cancel out to 1. We know sine over cosine is equal to tan. So this becomes tan squared theta plus 1, and 1 over cosine theta is equal to sec theta. So this is our second of our Pythagorean identities. And if we take our original equation and this time divide through by sine squared theta. Here, these will cancel out, we get 1. Cosine on sine is our 1 on tan, which is our cot. And here, 1 on sine becomes our cosec, and this is the third of the Pythagorean identities. So now we've got some examples. So I've put the identities up here for us to work from. We have 1 minus cosine squared theta. If we look at this original equation, we have sine squared theta plus cosine squared theta is equal to 1. If we subtract cosine squared theta on both sides, so that will cancel out over here, we get sine squared theta is equal to 1 minus cosine squared theta. So we know this 1 minus cosine squared theta is the same as sine squared theta. And here we've got sec squared theta minus 1. If we do the same with this second identity here, so we're going to minus 1 and minus 1. So that will become equal to tan squared theta. So here we put sine squared theta on our tan squared theta. And we know, well, tan squared is sine squared divided by cosine squared. So we can follow that through. We have our sine squared theta on 1 divided by here sine squared theta on cosine squared theta. So we're dividing by a fraction, so we invert and we multiply. Sine squared theta on 1 multiplied by cosine squared theta on sine squared theta. So these sine squared thetas will cancel out. We get cosine squared theta over 1 here is equal to cosine squared theta. So now looking at our second example, we've got something a bit more complicated happening here. So here we've got cosine squared theta multiplied by tan squared theta. We're going to work out what are we going to do with that. Well, here we can take our cosine squared theta out the front here, and then we've got 1 times cosine squared theta is cosine squared theta. And then here we take it out and we've got tan squared theta here. So now we've got cosine squared theta multiplied by 1 plus tan squared theta. And 1 plus tan squared theta is equal to sec squared theta. So multiplied by sec squared theta. And here we go, well, sec squared theta, here is 1 on cosine squared theta. So these will cancel out and we'll be left with 1. Okay, so now looking at number 3. we've got sec theta multiplied by cosine theta minus cosine squared theta. So we think, well, sec theta is 1 on cosine of theta. We're multiplying by cosine of theta minus cosine squared theta. So these will cancel out. Here we're getting 1 minus cosine squared theta. So if we look here, our first identity, 1 minus cosine squared theta is equal to sine squared theta.